Okay, guys, we're back at it again. We're going to be doing something called ratio and rates. And this is beautiful stuff. Everyone say it's beautiful. All right, let's start with a ratio first. So, first, it's important to know that a ratio is a fraction. Okay, a ratio is technically a fraction. All right, it has two separate numbers. Right, and you can find these notes in your text. It has two separate numbers, and basically it's written as, you see it could be written in three forms. And you'll see, so for example, if I ask, well, what's the ratio of 2 boys to 3 girls? Well, it's already written in one form here. So the first form is that you'll see a colon between the two. So it'll be like 2:3. So you're written with a colon, or it'll be 2, the word 2, 3. So the word 2, or it'll be 2/3, right? As a fraction. So these are the three ways it's presented itself. But what they don't tell you really is that the best form to start off your ratio in is in a fraction form. So if I said, what's the ratio of 4 boys to 6 girls? Okay, you necessarily won't have the option to say 4:6 or 4:6 or 4/6, because what we need to remember, the first thing is that a ratio is a fraction. And what we know about fraction, it must be in simplest form. So you would have to present your problem first in fraction form first, right? 4/6, which we know is actually 2/3, right? So the answer to this question is either 2:3, 2:3, or 2/3, right? So when you see your quizzes or assessment in WebAssign, actually, and this is for my students for the spring 2020 semester who would understand this. However, if you're a drop-in visitor, I hope you learned something from this. But I'm making references to students for 2020 semester, spring, during our COVID-19 saga, just having fun learning and staying indoor and healthy. So basically, like I said, ratio could be written in three forms: a colon, the word 2, or fraction form. The best way to set up your ratio problem is in fraction form, because it must be in simplest form. It must follow the rules of fraction, which is in simplest form. So you'll have to make sure that it's reduced first before you decide how you want to write your problem. And like I say, when you see your assessment is probably going to test you on all three forms and how to set it up. And basically, this is how a ratio is set up. So we could probably just work some problems. In a minute, we're going to talk about rate. Okay, so your wonderful text presented two problems. Is asked to write the comparison of 24 yards. So here's the problem right here. Okay, it says write the comparison 24 yards to 30 yards as a ratio in simplest form. Here they're giving you your warning using a fraction, a colon, and the word 2. So they're looking for all three forms of answers. So what you'll notice about ratio is that the units will be the same. You see, they're comparing yards to yards. When I give an example of a boy and girl, these are two human beings. Okay, so we're talking about 24 yards in comparison to 30 yards, right? And because we're going to be dealing with units pretty soon, you won't have your response in units because these units cancel out each other. So I'm going to use my old school method of reducing fractions. I'm going to prime factor 24, right? Which is 2 times 2 times 2 times 3. right? Because that's 8 times 3 is 24. And 30, I'll have 2 times, what's that? 2 times 15, 2 times 3 times 5. All right, so I can see I have a common factor, a GCF of 2 here and 3, a GCF of 6 in simple term. Or if you recognize right away that they had a common factor of 6 and that you can cancel it out, good for you. All right, and my remaining factors are 4 over 5. So here I have it in fraction form. And then I can have it in the colon and using the word 2. All right, so that's just one example of a ratio problem. Here they have another example of a ratio problem. It said write the comparison 18 meters to 16 meters as a ratio in simplest form using fraction, colon, and the word 2. So these are the types of problem you're going to see on your exam. Nice, easy peasy once you understand the concept. So we're asking to compare 18 meters to 16 meters. Right? And of course, meters will cancel out each other. And we know that the prime factors of 18 is 2 times 3 times 3, right? And the prime factors of 16 will be 4 factors of 2, actually. And we see that they have a GCF here of only just 2. And my remaining factors are 9 and 8. So my ratio is 9 over 8, 9 colon 8, or 9 to 8. So this is pretty much when it comes to dealing with ratio. Now let's talk about rate. Okay, so for rate, so while we have a ratio comparing the same units, rate usually compares 2 different units. It compares 2 different units. And it's also, and this is set up as a fraction in simplest form. You always put rate in simplest form, but usually the rates, they don't have any common factor. So a rate is in simplest form. If you like taking notes, a rate is in simplest form when the numbers have no common factors. When the numbers have no common factors. And you can find this in your text, in any pre-algebra text, I guess. So usually when you have a rate, when you're doing rate problems at this pre-algebra stage, you really do it. Many rates are written as unit rate. And what unit rate actually means, it's a rate in which the number in the denominator is 1, right? The number, that's hence the word unit. They're looking for 1, what it costs per 1, or what it is per 1. So that's what unit rate. So like I said, while ratio, we compare same units with each other, and the units actually cancel. In rate, we compare 2 different units. So let's take a look at an example. For example, and the denominator usually ends up with 1. So there's no like reducing of any fraction here. It's in simplest form, or you're looking for 1. So for example, they would ask a question like, write 190 kilometers in 2 hours. In 2 hours as a unit rate. So what they're actually asking for is, if it's 190 in 2 hours, what it is in 1 hour. That's basically what they're saying, right? And how you can do that, you could do that by a division, right? You remember, you set it up as a fraction. You do it by like a division. And, if you could see by hindsight that this is 95, good for you. So how many factors of 2 can we find in 19? We can actually find 9, which is 18. And how many factors of 2 can we find in 10 is 5. So it's actually 95 kilometers per hour, right? So that's another thing. You don't need to write 95 km over 1 hour. As a matter of fact, if you do that in some circumstances, especially in Web of Science, they probably mark it wrong. I'm not sure how they set it up, but it's actually 95 kilometers per hour. That slash actually means 1. Per also actually means 1. Per means 1. Per equals 1. Okay, let's see what another example would look like. Now you will see this problem in your text to the students that I'm speaking to in current time. They'll have 85 as a solution, but sorry to say the text did make an error. It happens. We are all human beings, and human beings are writing these texts, not robots. It's a sloppy error, but you know, I'm not innocent to making to doing things correctly all the time either, as is evident in some of my videos. Let's see if we could find another example of a unit rate. Here we go. Here they're asking to write 30 miles in 8 hours as a unit rate. You see, they're two different units, miles and hours. So let's see what that looks like. We set it up as a fraction. So write 30 miles in 8 hours. So let's see how much it is in 1 hour. So we're going to do our division. Right? We're trying to make sure that our denominator get to 1. And it's also okay for your solution to be in decimals. I don't know if they mentioned that here, but it's okay for your unit to be in decimals. I have to double check on that. Here we go. So 8 into 30, we can find 3 factors of 8 in 30. 3 times 8, 24. We have 6 remaining. We can add a 0. Then we can find 7 factors of 8 in 60. So we have 56. And we can add another 0 here. And we can find 5 factors of 8 in 40. So this is actually 3.75 miles per hour. Okay, let me just double check and make sure that I'm correct there. And boop, there it is, 3.7 miles per hour. So you see, what we see happening is that for our ratio, right, our ratio stays in fraction form. It stays in fraction form. It's always going to be two whole numbers, stay in fraction form, but our rate, it can be in both fraction form with the denominator as 1, or, you know, as they mentioned it, how they do it with a slash per, or in decimal form. Let's see if there's another example of a unit rate problem. Let's see. Here we have $78 for 15 ounces as a unit rate. So what they're going to want to know is dollar per ounce. So we have $78, right, over 15 ounces. So let's do some long division math there. And I believe you can find 5 factors of 15 and 78, which will give you 75. Add a 0. Bring it down, and we can find 2 factors of 15 in 30. So we always start off with what our dividend is. So our dividend was dollar, and that's ounce. So our unit rate would be $5.20 per ounce, right? $5.20 per ounce. Let's see how they wrote that. Oh, they wrote it with a slash. All right, it's important to pay attention to that. 5.20 per ounce. Okay, let's see. Let's step it up a notch. Let's see what else they're throwing at us with unit rate. Okay, so it's important to note when they step it up a notch, they bring question like this. So here they're giving you two separate units, right? They're saying a vehicle uses 15 gallons of gasoline to travel 537 miles. How many miles per gallon did the car get? Now be very careful not to form into the habit when they give you simple problems like this. Write miles in hours. So you set it up 30/8. Write dollars an ounce. So you set it up dollar/ounces. Right? Now be very careful. Look at the question here. The question here is now asking how many miles per gallon. So what has to come first is the unit miles. They're asking miles per gallon. They're not asking gallons per miles. So don't fall into the trap of setting up your problem the way it's written here, as in 15/537. It's actually the other way around. Look to see what they're asking, because they might have asked, how many gallons per mile, but in this case they're asking miles per gallon. So after the word per, that follows my divisor. So the first word that comes before per is my dividend, and after per is my divisor. So this is actually going to be set up as 537 miles over, what was that, 15 gallons. So now I'm going to do my division. And it doesn't necessarily means because the smaller number goes at the bottom. That is not always the case. It could be in the reverse depending on if they're asking gallons per mile. Okay, because it could be 0.00 something gallons per mile. And now I'm going to take care of this long division problem. Here we go. So how many factors of 15 can I find in 50? And that looks like 3, which is 45. What's that? 8. Yep. Bring down 7. And let's see how many factors of 15 can I find in 87. I have a feeling it's 5. 15 times 5 is 75. I'm going to do a little borrowing over there. This is actually going to be, oh, what am I doing? 7 subtract 5 is 2 and 1, right? So that's 12. I'm going to add my point, bring down a 0. And how many factors of 15 we can get in 120? And I have a suspicion that it's going to be a nice juicy whole number. Let's see. So I know that 15 times 7 is, 15 times 5 is 75. And 15 times 6 is 90. So I'm going to try, I'm not going to try 7 because I know 7 times 5 is 35. It's going to leave me with a 5 at the end. I'm looking for a 0 at the end. So I'm going to test it out with 8. So 8 times 5 is 40. And look at that. 8 times 1 is 8 and 4 is 12. Boom. Nice. So I am left with no remainder. So it looks like it's 35.8 miles per gallon. All right, let's see how they set that up in their answer so we can know how to put it in WebAssign. Okay, it looks like they write out the whole thing, 35.8 miles per gallon. So no shortcut when you're doing WebAssign. Maybe try it out. You're going to have to write the whole thing. I'm not sure how they set it up. All right, so that's it for unit rates and ratio, my friends, at this stage of the game. We're going to be moving on to the next.